He is a physical scientist with the Applied Sciences and Geospatial Solutions divisions of NOAA's Office for Coastal Management. He is located in Charleston, South Carolina, where he leads up NOAA's land cover mapping activities, managing the Coastal Change Analysis Program. Nate also has a bachelor's degree in soil science from Penn State University and a master's in geography from George Mason University. He has been with OCM for 13 years and came to the NOAA from the private sector, where he was involved in the production of land cover map products worldwide.
All right, thank you. Glad to see that folks stuck around after lunch and came by to see what we had to say about land cover. I think seems like the presentations we had in this session are going to be some good ones. So, as Josh mentioned, I am from NOAA, the Office for Coastal Management. I lead up our Coastal Change Analysis Program. I'll talk to you really about kind of two things today. The main thrust of what I want to talk about is the future direction that we're going with our land cover mapping efforts and what that means in North Carolina. Before that, I figured it would be helpful to have some background for those of you who may not be familiar with what it is that NOAA does. So maybe I'll start off with just a question. How many folks in the room have heard of the Coastal Change Analysis Program previously? Used the data? Okay, great. How many of you have heard of the National Land Cover Database, the NLCD products? Great. So for those of you who raised your hand on my second question and not the first, you've already been using CCAP data. You just didn't know it. CCAP is NOAA's Coastal Change Analysis Program. It is our national coastal land cover and monitoring program. So all the areas that you see here in blue are the areas that NOAA maps with that product. Those are also all of the areas where we map for NLCD. So all of the data that we develop for CCAP is directly incorporated into the NLCD products. That works out to be about 25% of the lower 48. USGS maps the other 75% themselves and make sure that the products we produce and the products that they produce are nice and seamless. And it's been a really great relationship. These are all, I should have said earlier, one of the product lines that I'll give you a little bit of background on. This is what we call our regional product line. These are the ones that people are probably most familiar with in terms of CCAP and NLCD. That's because they're based on the 30-meter Landsat data. They're data sets that we've been developing now for decades. One of the things that I would note in terms of a little bit of the differences between NLCD and CCAP, for those of you who are not familiar, is that we had a little bit of additional detail in terms of the wetland categories that we map in the coastal areas. And in many areas of the country, we have dates that go back a little bit further in time. In the Great Lakes, for example, we've had funding over the last several years that have created data sets back into the mid-80s, all the way back to 1975. So we've got a 40-year time series of data that'll be coming out as we complete our 2016 update there. So I mentioned the added wetland categories that we map. The categories that you see here in blue are those added wetland categories, nested within how they kind of roll up into the NLCD scheme. NOAA typically has made probably as much efforts towards making sure that the data that we produce is useful and used by folks in the coastal areas of the United States. This is just one slide where I'd like to highlight a few of the tools that are available within our Digital Coast website. For those of you who are not familiar with that website, it's kind of a platform that NOAA makes tools, data, training opportunities, and other resources that we feel like those who are focused in on coastal issues would be most interested in. If you're not familiar with CCAP, or if you're not exactly familiar with land cover in general, the Land Cover Atlas, the first one on the list here, is probably the best place to start. This is an online tool that we developed to help people kind of get at some of the change information that you can pull out of the land cover data. We realized that some of the complexity in terms of that change information and expecting people to think in if-then logical statements didn't always quite work out so well. It was one of the most frequently asked questions we always got. So kind of derive some of that information for folks, so we went ahead and built a tool. Also, anyone's interested, I do have at least a handful of copies of a report that we put together when we finished our last update in 2011 on the changes that we've seen. This is in the Southeast since 1996. A lot of the other tools in the list, good examples of where we highlight how that data can be used to support other kinds of applications. It's incorporated into our Sea Level Rise viewer to help predict where wetlands could potentially be lost or migrate to in future sea level rise scenarios. We incorporated into several what we call coastal county snapshots focused on wetland benefits and flood risk. And we have several tools where you can download the data and run a much more customized analysis. Habitat priority planners focused in on kind of locating conservation areas or other priorities. OpenInspect's a water quality tool where you can get some information that focused in on non-point source pollutants. So I mentioned we have two main product lines. The other is kind of a higher resolution, more detailed, spatially counterpart to that regional product line. This is something that typically we develop more of a hotspot in hotspot geographies, where we have projects or partners who have a need for that more detailed information. This can be based either on aerial or satellite imagery. We've been doing it for a number of years now, not quite as long as we've been doing the Landsat-based data. And the main reason that we haven't done it in more locations to date has been the cost that's been associated with those products. As you can probably imagine, developing data that's more detailed is a little bit more expensive and a little bit more time-consuming to produce. One kind of exception to that rule has been in the Pacific and at least a portion of the Caribbean, where we made a wholesale decision a few years back to not map there in a Landsat scale at all. It just really wasn't appropriate for those geographies, and have been mapping there using QuickBird and WorldView data now for several years in all the islands of the Pacific, including Hawaii and the territories. We have at least 2 dates of land cover data and are working on a third for Guam right now. And in the Pacific or the Caribbean, we have 3 dates in the USVIs for each of those islands, and we just recently released our first date of data for Puerto Rico. And all those data sets are either 2 or 2.4 meters in terms of resolution. So to give you a little bit of an idea on what those high-resolution products that we develop look like, maybe I should, before I get into this, should say 2 things. One, we are not really a research organization. We are much more of a production shop. So you may see a little bit more interesting things. If cutting-edge technology is kind of what you're looking for from our other 2 speakers today, we like to make sure that things have been tried and true and proven before we go off and spend taxpayer money on them. And the other thing I should note is that I should have some truth in advertising here. In all reality, we don't do much of the actual pixel pushing ourselves. We do some, but most of our work is actually accomplished through contracts to private industry. And that's actually been a really great relationship. We can take advantage of the expertise and the capacity and the knowledge that they have without having a lot of folks on staff and having to do a lot of work ourselves. And I think it actually also has a really good added advantage that we are somewhat unbiased from the classifications that those companies produce from us, and are able to kind of pick them apart as they're being developed to make sure that they're a higher quality product in the end. So this is one example. This example is actually from southern Maine, around Kennebunkport area. NOAA has one of their national estuarine research reserves located there. This is the Wells Reserve. And there's 2 things I like to point out here. One is what we're looking at is a salt marsh area there on the left of your screen. Just the level of detail that you can see there in terms of the tidal creeks that we're capturing, the pans, the pools within that marsh that you can see. The other thing I like to point out is a little bit of the technology behind how we produce these products. On the right-hand side of your screen is the imagery, or at least one of the image data sets that was used to produce that land cover product. Overlaying on top of that are the polygons or the image objects that we use in the classification of those data sets. So we don't map each pixel, we map groups of pixels based on software that groups them into like polygons. And that just makes our job a little bit easier in gives us actually added information that we can use to not have to push around each pixel and get a little bit more contextual data to feed that classification. So here's an example of what our two products might look like side by side. This is for an area down in the Panhandle of Florida, Bay County, around Panama City. The 30-meter product you see there on the left, the high-res product, in this case it's a 2-meter product there on the right. And again, I have two things I like to point out. One is that in general, especially outside of the developed features, these two products capture very, very similar trends and patterns of land cover for the area. The other thing I like to point out is that if you are looking to do something inside of that developed area, the 30-meter data probably doesn't provide you a whole lot of detail, whereas the high-res data does. You can see individual areas of impervious surface, whether those are grasses or tree canopy inside of there, whereas you don't really know at the 30-meter scale. And if I carry that to somewhat of an extreme and zoom in even further, and kind of a caveat here, this is not the level that the 30-meter data is developed or intended to support. So this is, if you're ever looking at it this close, you're looking too close. Zoom back out. But if this is the scale at which you are working, obviously those 30-meter products break down for you, and something along the lines of what you see here on the right is something more along, would be much more appropriate. This product is actually an example that we'll get into a little bit further along, where it gives you kind of a little hint of where it is that we're actually heading. It's a 1-meter product based off of MAPE and LiDAR data, developed initially to produce a 6-category land cover product, and as you kind of see later on, our intention is to take that 6-category product and start to walk it out to some of the CCAP level classification that we saw earlier in my presentation. So I kind of let the cat out of the bag there on the last slide, but essentially what NOAA has decided to do is to try to start moving away from our 30-meter level mapping and to move more towards mapping at that higher resolution everywhere where we map, so that coastal area, the 25% of the lower 48 that I highlighted at the very beginning of the presentation. It's the cost of that mapping has come down, and we've actually negotiated some bulk discounts with a company that have made that even much more reasonable than it has been in the past, but it is still more expensive than what it has cost us to produce those 30-meter products to date. So we've decided to start taking those steps, but have realized that it's going to take us several years, maybe several phases, to move through that transition. And so what I kind of call those steps that we're taking is making a down payment on that future state. And what that really means is we're going to start immediately. We already are working on it, actually in the area highlighted here in Washington State, developing those 6-class products at that 1-meter resolution now. The 6 categories, if you didn't pick them up in the last slide, it's impervious, bare, grass, shrub, forest, and water. Most of that data is based on MAPE imagery, LiDAR information, though it's not dependent upon those sources. That's just kind of the lowest common denominator, things that are available everywhere. If a state has another collect, if they have a leaf off collect, if they have low tide imagery, we make use of all of those data sets as well. We make use of a lot of ancillary data to make our job easier. And essentially, I kind of mentioned the cost is still an issue here, and that we're going to be working through phases. And the main reason for that is what we can afford right now is actually a restricted level license product. And what that means is that immediately NOAA will be the only person that can, or the only entity that can use it. And that may sound absolutely horrible to you, and I agree it's not our ideal state, but in a few minutes I'm going to tell you why I think that's still a good thing and a good move on our part. First, though, I'm going to show you what a few of those products look like. These are draft products that we've started developing today. But, I forgot this slide, even before that, I'm going to show you just a little bit of the workflow and how those products are being produced. So essentially, what we do is take that imagery, run it through an image segmentation algorithm. In this case, we're working with a company that makes use of Workio's toolbox, QGIS. Feeds that into a sampling scheme. This is just an example of where they take samples in an area such as California. Those samples then are used as training into a CART classification process. Eventually, modeling and expert knowledge comes into that, produces a product that you see up here in the kind of the far side of the screen. And at that point, there would also be some manual editing to clean up anything that those models in the automated classification really didn't pick up all that well. And this would kind of be the extent of that baseline product that I mentioned in the last slide. So what do those products look like? This is a couple of screenshots of the draft products that we have right now in Washington State. Altogether in Washington State, we're mapping about 36,000 square miles. This is an area here in the nape imagery around the Seattle-Tacoma Airport. You can see the runway there on the left-hand side of your screen. This is what the land cover, the draft land cover for that area looks like. I can switch back and forth through there a couple of times so you can kind of get a feel for what it looks like. And I can compare that to what the 30-meter data looks like. And again, two things to kind of note here. Major areas of forest or tree canopy are actually coming out pretty well in those 30-meter products, but it's just not the same level of detail that you get out of the 1 meter. And if we zoom in a little bit closer, this is about 1 to 10,000 scale, you can kind of see the same example of what those products look like and how they compare to the 30-meter data. So, obviously, a restricted level data set is not what NOAA is after. But like I said, we can't afford to do it all in one foul swoop, so we're going to take the steps to do that anyway. And I mentioned that I was going to give you 2 reasons why that's a good thing. Here's the first. We can use those 6-class 1-meter products immediately, resample them up to a 30-meter, and use those as a direct input to update our 30-meter data set. So we have a 30-meter time series that we do not want to completely abandon and walk away from. It's a useful product. It provides a lot of trend and change information that we know folks will find useful going backwards in time. So we can update those products in the very near term and not really disturb or break the system that we've already put into place. Here's just a little kind of a simplified workflow of how that would work. We take that high-res product, we resample it up to a 30-meter, create essentially a 6-class 30-meter product, use that in conjunction with a Landsat-based change detection to isolate the areas of change, and then go through a little bit of magic where we have some ancillary data and our past land cover and a lot of expert knowledge where we feel like we can get back to our full classification scheme. The added advantage that we see over that is that not only have we maybe found a more expensive way to produce our 30-meter products, but we've also provided an alternative to those 30-meter products where we think there's derivatives that can be very, very useful. Percent impervious, percent canopy, percent any of those other 6 categories that we map can all be derived and provided free of charge at that 30-meter resolution, and they should be much better products than natively derived 30-meter products that are similar. The other reason I think this is a really great move on our part is that it builds the foundation for the future. Essentially, the analogy I like to use is that we're kind of building a new house, and this is the foundation for it while we are living in our existing house. And so we have a couple of pilot geographies where we're currently working to figure out exactly how that would work. And what I mean by pilot geographies, these are areas where we will actually pay to unrestrict the product and pay to incorporate all of the categories that CCAP maps. So you can see there's a few of those highlighted in green. Here again, Washington State is going to be the first of those. These will be products that we can use to help us figure out that process in its entirety. They will be products that will help us figure out what that process costs, because we've only done it over smaller areas in the past. We've paid very boutique level pricing for it, hundreds of dollars per square mile. We expect very significant cost savings going forward into the future. And again, our long-term vision is that we can unrestrict those products and incorporate those full CCAP schemes between this update cycle and our next update cycle, and move away from what has been a Landsat-based time series in the past and really result in a high-resolution time series going forward in the future. And really kind of the key here again goes back to that first good reason. A common year that ties those 2 product lines together will be kind of key to making sure that the status, trends, change information that we produce kind of seamlessly goes across that time frame. So, it's not all bad news either in terms of you might have to wait several years. We're actually offering up quite a few opportunities for folks who might have interest in this product. Obviously, we are actively seeking additional funding that would allow us to do this as fast as we can. In lieu of that, there are several opportunities that we can point out to folks where they can take advantage of what it is that we're doing. Any of the regional updates that we produce and any of those pilot areas that we produce will obviously be something that we provide free of charge. Those will be things that you can find available on our Digital Coast website when they are finished. But we're actually offering and coming with a little bit of a sales pitch in this as well, in that we're looking for both, one, confirmation from folks that moving to a higher resolution is the right thing for us to do, and that it is worth that cost and potentially the wait. Two, if folks are interested in moving to the high resolution and they want to help us make that happen faster, we are more than open to partnership opportunities to share the cost of that development. And we think that can be kind of a win-win relationship in many ways. Obviously, NOAA would benefit from any money that any partner would put into our system. It would make those products publicly available and something that we could distribute that much sooner, which is where we want to go. But what NOAA offers in return is essentially taking advantage of both the bulk discount that we have negotiated with our private companies that do the work for us, as well as we're putting the first couple of dollars into the pot for that data development. So you can potentially get a product for far cheaper than you might otherwise on your own. In addition to that, I note a couple of other things here on this slide. One of those is that if you all are helping pay, or if any of our partners are helping pay, you should get the area interest that you're interested in. NOAA typically looks only in those coastal areas. You've had to rely on NLCD products for the interior, where they may not match up in terms of some of the dates in the past, or the timeline and how fast those products are produced. There's no reason that the partnership opportunity that I'm talking about here couldn't be extended into full states outside of those coastal areas. And in addition, if there are categories of CCAP that you're not interested in, those wouldn't be ones that you'd have to pay for. There's categories that potentially go beyond what CCAP would be interested in. Those are obviously things that we can talk about in terms of options. And so I just kind of close my presentation here with just a couple of questions for you all to consider. Again, I'm hoping to hear some feedback. This is actually probably the first I've really reached out to folks in North Carolina on what it is that we're trying to do. Part of that is because I've been focused in on some of the areas that we're working in much more immediately. It'd be great to hear kind of confirmation that this is of interest to folks, that this product would be something that you'd be interested in. Certainly be interested to hear if anyone would be so interested that they might want to talk about what the cost would be. And if you are interested in that kind of opportunity, how that might work, what categories you're interested in, what geography you're interested in would be questions that I'd ask. And so with that, I thank you for your time and ask whether there's any questions. I think we have a couple minutes. Yeah, so the question was about the licensing and why we're not able to provide the data external to NOAA. Cost. Essentially, what we're paying is several dollars per square mile for the restricted product. An unrestricted product would be another couple dollars on top of that. Given the budgets that NOAA has had in the past to produce our 30-meter products, we just don't have the money to pay for the full cost. So it comes down to we would either have to choose not to map everywhere that we map and walk away from some portion of a coastal area, or we can do this product and kind of work over several years. The trade-offs there were that was a tough decision for us. Yeah, so right now in North Carolina we have no high resolution. All the data sets that we have in North Carolina are the 30-meter regional products from 1996 to 2001 and 2006. And when we get through this mapping, we'll have a 2016. I think I left off 2011. The area that I showed in green, that was that high resolution baseline product that I'm calling it. So that's an area where we currently are planning to develop these 6 category 1 meter products, but they will be restricted in terms of the licensing. So we'll be producing our 30 meter products using those high res data sets, but it won't be something that we can distribute initially. Yes. Yes. Not off the top of my head, but we can talk a little bit more about it. Part of it is we're working through some of those pilots to see what kind of things we can end up cleaning up and what other classification we do on top of those 6 once they're complete. To kind of give you an idea of what we're talking about is we kind of expect that what we're putting into the system right now is about $3 or $4 per square mile. We kind of expect the licensing alone to be about another $1.50 per square mile. And we expect that there's probably a little bit of cleanup that you'd want to have happen in addition to that licensing restriction. That might be another couple of dollars per square mile. And that all told, getting into the CCAP scheme of things might cost somewhere around $15, $20 per square mile total. If you compare that to some products that we've seen that have been developed very similar in terms of 6-class products, those things have been more along $45, $50 per square mile minimum. We've paid about $100 to $150 most recently in the past per square mile. Yeah. Yeah, so I mentioned this is the first time kind of reaching out here in the Southeast. In the state of Washington, we've had pretty good response. Might have a lot to do with the fact that we have such a large pilot geography there for them. Can't really complain too much about that. We've also had a really good response in New England. The states of Maine, New Hampshire, and Massachusetts are all very, very interested in playing into what we're doing. And if you're not familiar, the Chesapeake Bay program just recently released a data set that covers all the counties that touch the Chesapeake Bay watershed. Virginia up through Delaware, Pennsylvania, New York, very similar product. We're actually kind of stealing their data and working with it as if it was our own. All right, well, thank you.